Hello, everyone. Mr. K here again. We're talking today about, if I can get my PowerPoint to roll here, corrosion. All right, we're going to talk about corrosion, erosion, which is really could be considered part of corrosion, oxidation, also related, dissimilar metals corrosion, and ways to prevent it. How do we stop it? So what is corrosion? It's a natural process. Notice it converts refined metal into a more chemically stable form. So metals naturally want to corrode. I'm sure a chemist could probably teach this lesson better, but I'm trying to make it easy to understand and show you how I understand it. Metals naturally want to corrode. We stop them from corroding by artificial means, such as painting them, coating them in oil, that type of thing. But really, if you just leave them in nature, just throw a piece of iron, steel, aluminum out in nature and just let it sit, it will corrode. That's just their natural tendency. And it's also considered the gradual destruction of those materials. Okay, people often mistake this as rust. They'll look at a piece of copper pipe that's turned green because of a water leak and they'll say, oh, it's rusty. That's not rust, that is corrosion. Rust only refers to ferrous materials or materials that have iron in them. So rust is reddish brown. So that is not rust unless you're looking at the wire that supports the pipe. That is not rust. That is aluminum corrosion. That is rust. That is iron oxide that has been corroded. Or I'm sorry, it's iron oxide. It's iron that's been corroded. Okay. Found this interesting. Corrosion of carbon steel or rust doesn't occur below freezing. So why is my question to you? And since you're not here to answer why, the answer is because below freezing, water is not going to be present in the air anymore. So moisture is going to be snow or ice, or there just won't be any in the air. And it falls to the ground, or like I said, it's not suspended, so it's not touching those materials. It's not going to, it's not, that ingredient of moisture is not available anymore to cause corrosion. I also asked, does it speed up or slow down with salt water? The answer is it speeds up. Salt, and again, this gets into too deep a chemistry than I want to get into and that I know, but salt will speed up rust, will speed up corrosion on aluminum, all that type of stuff. All right, go ahead and pause my video and watch this video at this time. All right, so let's talk about erosion. So if you think of erosion, you might think of dirt erosion, like a road getting washed away into the ocean or into a big lake. And it's kind of along that same principle. So this is a water pump or a water impeller. Here's another example of it. Notice if this was something that was just thrown out into a backyard and rained on for 10 years, it would have what they call general corrosion, where the corrosion would be uniform. That's not the case though. It's eating away at these blades in a certain spot. Notice that. Okay, it's eating away at the blades. So erosion is a degrading of a metal surface, typically caused by some kind of mechanical action. Could be several causes, but the point is it's caused by a fluid or something that's rubbing this or that's pushing around this. So in this case, it was probably just a fluid that has been going past these blades for years, and it aided in kind of a corrosion process, but that's erosion corrosion. All right, oxidation. So reaction between oxygen and a material that will change the surface of the material. This causes rust. This is not the same as rust. But notice I said materials, I didn't say metals. Because paint oxidizes. Okay, there's oxidized paint on a truck, oxidized paint on the side of a house. If you take your hand along a old house, like a house built in maybe the 50s and it hasn't been painted since then, it's got the original white or light colored paint on it, or any color, I suppose. Run your hand along it, you'll get chalk on your hand. It looks like it's kind of chalking paint. That's paint that's oxidizing. It's degrading just like metal does with time and oxygen and sunlight. Plastic oxidizes. Remember, oxidation doesn't mean rust, because plastic, it doesn't rust. So that's not rust, that's oxidation. It's degrading of the material with moisture and ultraviolet rays as well. Doesn't help. Food rust, or food oxidizes, excuse me. All right. So let's leave oxidation. Let's talk about corrosion again. So one other type of corrosion I want to talk about that's very common in automotive world is dissimilar metals corrosion. That occurs when certain metals touch. Okay, not all, but again, here's a example of copper and steel, and this is an example of possibly brass, maybe copper. I'm thinking that's brass, hard to tell, and cast iron pipe. So those have reacted right where they met, and it's caused a great deal of corrosion. Okay, not all metals will do that. If you touch, I mean, if you have gold touching steel, it won't do that. Nickel touching steel, it will not do that. For example, zinc and steel won't do that. So it sort of speeds up what would just be normal corrosion that would take, maybe 100 years to eat through this pipe. It might happen in 5 years if it's got dissimilar metals. Okay, so how do we prevent it? We know we've got corrosion, we know how it happens. How do we stop it? Well, the most obvious way is to paint it. Paint the metal. It'll stop corroding. Also, you could pour oil on it. And I'm going to ask you now, why does that work? And the answer is because oil and paint separate that metal from the oxygen in the atmosphere and the moisture. So they just form a protective barrier. There's nothing magical about the paint or the oil that affects the metal. It just makes that barrier so that the oxygen and moisture can't get to the metal to cause a chemical reaction. There's also something called conversion coatings. Example of this would be like iodine coatings, which is typically only used with aluminum as far as I know, but conversion coatings is not the same as plating. So nickel plating and chrome plating is not a conversion coating. A conversion coating, such as iodine, does not add material to your original part. So if I conversion coat something to prevent corrosion, that part will be exactly the same size down to the 1,000th of an inch. If I chrome plate it, I'm actually adding a layer of plating on the outside of this part. This part actually becomes slightly bigger. Okay, so plating, you're adding metal or you're adding something to that part. You can also separate the two layers of metal. This works great for dissimilar metals corrosion. Here is our friend anti-seize. So if you ever wonder what the story is with, this doesn't say nickel on it. A lot of times it says nickel anti-seize. It's because nickel does not react with a lot of things. It doesn't cause dissimilar metals corrosion for the most part. So if you put nickel between two layers of metal that would typically corrode when touching each other, you won't get that dissimilar metals corrosion. So that's one reason. It doesn't wash away as easily. So that's one reason nickel anti-seize is pushed real hard to prevent corrosion. Okay, not the same as Loctite. I do want to clear that up. You put this on threads. Loctite is a glue, essentially. Loctite's just glue that you put on the threads of a bolt to stop it from coming back out again. Anti-seize is something you put on the threads of the bolt to make sure it will come back out again and it won't get rusted in place. So they're sort of opposites in a way, are used in opposite manners, but Loctite is just a glue to hold the bolt in so it doesn't get loose. All right, at this time, go ahead and complete your assignment on corrosion and have a good day.